Okay, here's our second net force example, and this is an example where we have a vertical applied force, or sometimes called a tension, especially if you're talking about an elevator and a cable having a tension. Tension and applied force are the same kind of idea, but tension is just an applied force that's acting through a cable or a rope. So in this question, it says a 35 kilogram crate is lifted by a forklift with a force of 380 newtons. What initial acceleration would the crate have? So you still want to draw your free body diagrams. So this is our 35 kilogram crate. You notice I use a crate so I don't have to actually draw and show my art skills. But we basically have an applied force that's up. The forklift lifts this crate, and this 380 newtons is that applied force. What is often forgotten is that there's always a force gravity presence. So those two forces are opposing each other. And if we were to look at the net force equation involving these forces, we would say the net force is equal to the applied force plus the gravitational force. This is a vector formula, which is the reason why I have those little vector symbols above our force equations. If I then take my vector formula and consider what it would be in terms of just scalar, or in terms of our equations, I would then realize that my applied force, because it's up, and my gravity, because it's down, would have to be subtracted from each other to find the net force. And so that's where I get my one equation from. After I draw my free body diagram and consider all the forces that are acting, I then figure out what my equation would be. Because the two forces are opposing each other, I subtract them. So the net force we can rewrite as mass times acceleration. The force applied, well, that's the 380 that we're told the forklift applies to the crate. And the force gravity, that's equal to mg. And so if the mass is 35, the kilogram is 35, the crate is 35 kilograms. So 35 kilograms times the acceleration is equal to 380 Newton applied force minus the 35 kilograms times the 9.81. Subtract those two forces and then divide by the 35, and you should end up with an acceleration about 1 meters per second squared.